We are completing a dosing problem. When we look at the order, we see 0.75 grams every 6 hours IV push is ordered. We're told based on the package label, reconstitution directions, how many milliliters of the med should be administered per dose. So we have our three methods. To use any of those methods, we need to know what's ordered, which we clearly see in the problem as 0.75 grams. And we need to know the strength of the med. So we're going to look at the label that's given. We see the 1 gram, but that is not per any volume. So I can't use this information in the strength of the med. The prompt told me to look at the reconstitution directions. So I'm going to be looking at the fine print. The first part of the reconstitution directions say for IM use. But when I look at what's ordered, this is ordered as an IV push. So I continue and further through the fine print, I find for IV use. It tells me add 10 milliliters of sterile or bacteriostatic water for injection, USP. And then it tells me, and this is very important, each milliliter contains 100 milligrams of this medication. Sorry, I'm not real good at underlining sideways there. So that's the strength. Each milliliter with 100 milligrams. And I'm going to write it the way we normally see it. We usually see the med on top of our fraction. So we usually would see 100 milligrams. And we would see that written over 1 milliliter. So from the label, this is the strength that we're using. Now let's look at the different approaches. In dimensional analysis, we start with the order. So in this case, the 0.75 grams. We place that over 1 as a placeholder. We want to use the strength of the med to cancel the grams, but the strength of the med is in milligrams. So next I will insert a conversion. I want to cancel gram, so I'm putting that on the bottom. I want to change it into milligrams to use the strength of the med. I know that 1 gram is 1,000 milligrams. My next fraction is to use the strength of the med to cancel the milligrams. So I'll put the milligrams on the bottom. I'll put the milliliters on top. And we have that there are 100 milligrams per 1 milliliter, and that cancels the label of milligrams. So I'm ready to do the math. So 0.75 times 1,000 divided by 100, and I get an answer of 7.5 milliliters. The second approach is to use the nursing formula, which starts with the desired amount or the doctor's order, in this case the 0.75 grams. We place that over what we have, and we have 100 milligrams that is in a quantity of 1 milliliter. We're not ready to do our math because our labels do not cancel. So I'm going to use the King Henry. You remember King Henry died by drinking chocolate milk full of microorganisms. The G is a base unit, and if I look at the jumps on the metric line, I need to move my decimal 3 places to get to milligrams. So this would be the equivalent of 750 milligrams. Now the labels do cancel and I can do the math. So cross out milligrams, 750 divided by 100 times 1, and I get an answer of 7.5 milliliters. The final method is the proportion method, which is the equal fractions method. Again, we'll start with the order of 0.75 grams. We'll place it over X milliliters because that's what we want to change it into. And we try to match it with an equal fraction. And so we know that we have 100 milligrams per 1 milliliter. Now this is not a true proportion because my labels do not match. So again, I have to use my metric line. And so I remember King Henry died by drinking chocolate milk full of microorganisms. The G is a base unit, and I have to move my decimal 3 places to get 750 milligrams. Now I have a true proportion because my labels match, so I use the cross product. My first diagonal, 750 times 1, is 750. My second diagonal is x times 100, and we usually write that 100x. Divide both sides by 100, and that gives us x is equal to 7.5. And our label on that is milliliters as it was in our original proportion.